A car of mass 1250 kg travels from the bottom to the top of a straight hill with a length of 400 meters and inclined to the horizontal angle alpha, where sine alpha is equals to this. The resistance to the car motion is 800 newtons. Okay, the car is going upwards, then the resistance would be downwards. Find the work done by the car engine in each of the following cases. Okay, so when the car speed is constant. Okay, so I'm going to use energy formula, work done by driving force plus loss in energy equals to work done by resisting force plus gain in energy. Okay, so we have to find the work done by driving force, that would be X plus loss in energy. As this goes up, what kind of energy is lost? Definitely not potential energy because it's increasing, and also definitely not kinetic energy either because the speed is constant. So kinetic energy both at top and bottom is the same. So here there's no loss in energy in this system. So we write zero here. Work done by resisting force. We're not giving that, but we're given that the force is 800 and the distance is 400. So work is equals to force times distance plus gain in energy, which is the potential energy, which is going to be this mgh. So m is 1250, g is 10, and height would be 400 sine alpha. So 400 times 0.125. So this is mgh. So it's going to be times 400 times 0.125. Solve this and get the value of it, which comes out to be 945,000 joules or 945 kilojoules. Okay. Let's take a look at the second part, which says, again, find the work done by car's engine when the car's initial speed is 6 and the car's driving force is 3 times greater at the top of the hill than it is at the bottom. And the power output is 5 times greater at the top of the hill than it is at the bottom. Okay, again we have to find the work done by driving force. Okay, let's redo. Okay, work done by driving force is X plus loss in energy. So we have to see whether the speed upwards increases or decreases. First, we need to find the speed at the top here. Then we can determine whether it's an increase in kinetic energy or a loss in kinetic energy. Okay, is equals to work done by resisting force. It's going to be the same. Plus energy gain is also going to be the same, mgh. So m, g, and h is this again, which came out to be 50. Okay. Now we have to find the speed of the particle at the top so that we can figure out whether it's a gain in kinetic energy or a loss in kinetic energy. Okay. So now let's make use of these equations given to us. Driving force is 3 times greater at the top of the hill than it is at the bottom. Okay. So driving force at the top of the hill is three times greater than it is at the bottom. So driving force bottom is three times the driving force at the top. Also, the power output is five times greater at the top. So power at the top is five times greater than at the bottom. Let me reread that. The driving force is three times greater at the top. So driving force at the top is three times greater than the driving force at the bottom. And power output is five times greater at the top than at the bottom. Okay. Okay, I've rewritten that. Now let's solve these and somehow get the value of V to determine whether it's going to become bigger than 6, then it's going to be a gain in kinetic energy. And if it becomes smaller than 6, then it's going to be a loss in kinetic energy. Okay, so power is 4 times V. So force at the top times speed at the top is equals to 5 times force at the bottom times speed at the bottom. Okay, speed at the bottom is 6, so I'm writing 6 here. Force at the bottom is driving force at the top divided by 3. Or in fact, what I can do is change this with force at the top. These are the same thing, by the way. Okay, is equals to 3 times force at the bottom. So I'm writing 3 times force at the bottom. This and this cancels. We get V is equals to 10. So the speed at the top is 10. Okay, now that means there's a gain in kinetic energy. So this there's a gain in potential energy and a gain in kinetic energy as well. Okay, let's use the space now. Okay, so gain in kinetic energy is going to be half times m times squared of the bigger speed, which is 10, minus squared of the smaller speed, which is 6. Solve this and get the value of x, which is the driving force, work done by the driving force. Okay, when you solve this, you should get 985,000 joules or 985 kilojoules.